Here's a few reactions over your types of reactions review sheet for your chemical reactions test. Looking at the directions up here, first thing I do is tell the type of reaction. So you got single replacement, double replacement, synthesis, decomposition, combustion. So those are your 5 types of reactions. If it is a single replacement, tell if it's cationic, which means it's a positive replacing a positive, or anionic, or if the reaction occurs. So for single replacements, you're going to look at this activity series. These ones right here are the anionic. That'd be a negative replacing a negative. These are cationic, a positive replacing a positive. Okay, again, the bottom tells you elements cannot replace things above them. So the element by itself cannot replace things above it on this reaction. Otherwise, it's no reaction. If it's a double replacement, circle the precipitate. So that'd be your solubilities. Remember, if it's a precipitate, that means it is not on this list. It is not soluble. It'd be the solid substance you see being formed. Okay, so I'm going to do about 6 of these reactions on this sheet for you. First I'm going to do is number 1. So we got magnesium metal, so just magnesium, reacts with lead, sorry about the glare here, lead, Roman numeral 2, sulfate. Roman numeral 2 means that lead is a positive 2 charge, sulfate is a minus 2 charge. So when it says reaction, that's plus, lead, sulfate, plus 2, minus 2, so we're good. Looking at this, we have a compound and an element. That means it is a single replacement. The element by itself is trying to replace something in here. So look at your activity series and see if this reaction happens. So look down this list, and if you look on here, magnesium is above lead. Magnesium is above lead, so magnesium can replace lead. So this is trying to replace that. This is called a cationic. Again, cationic means it's positive. Single replacement reaction. Magnesium replacing lead. Other side of the equation, we get magnesium sulfate plus 2 minus 2 charge, so we're good there, plus lead. Lead was kicked out. Everything is balanced in this case, so we're good to go. Don't put any coefficients in to balance it. Again, that's a single replacement. The reaction does happen. Second one here, we have iron bromide with potassium carbonate. Those are 2 compounds. That would be a double replacement reaction. Iron's charge is a plus 2 because of the Roman numeral. Bromine's a minus 1. So we got FeBr2 plus potassium carbonate, which is a plus 1 and a minus 2. Carbon 8 is off your polyatomic ions list, so it's CO3. Need 2 potassiums. Okay, double that. And 1 of this group. Again, if you want to put it in parentheses, you can. We just need 1 of that group, though, so we're good there. It's double replacement. So the Fe and the K are switching places. Fe and the K are switching places. Double replacement. So the Fe goes with the CO3. And that's still a plus 2 for iron and a minus 3 for carbonate, so those are equal. The K goes to the Br. Plus 1, minus 1 charge for those, so those are good. Put in coefficients to balance it. We've got 1 Fe, 1 Fe, 2 Brs, only 1 over here, so we need 2 there. That gives us 2 Ks, 2 Ks. I think we're good. Everything else would be a 1 in front of it. Whenever it's double replacement, you need to circle the precipitate. Okay, figure out the thing that is insoluble. So you look on your list here. Okay, look at your sheet. You try and find the thing that's not on there. Well, it tells you on here that anything with potassium in it is always soluble. So this compound would always be soluble, so that would not be a precipitate. That would be dissolved. Fe's on this list, and CO3's not on this list. So this is your precipitate. That'd be the solid substance forming that reaction. Again, that's only for double replacement reactions you do that for. Third one, magnesium and nitrogen combine. So we have magnesium and, so plus nitrogen. Always look and see if those are diatomics when they're by themselves. Magnesium is not one of the diatomics. Nitrogen is diatomic. So they're going to combine and make a compound. So this is going to be a synthesis reaction, taking two things, making them into one. So they form magnesium nitride. Look up your charges. Magnesium is a positive 2 charge. Nitrogen is a negative 3, so it's Mg3N2. Make sure it's balanced. A 3 with magnesium, so we need a 3 over here. Again, that means there's 3 magnesium atoms that are separate, not combined. 2 nitrogens, we're good there. So there's 1, 2, and 3. The next one I'm going to do is going to be number 6, I believe. No, number 5. So here's number 5. I skipped number 4. You guys still have to do number 4, but I'm just skipping it. It's another double replacement. 4 is. 5, we have sodium reacts with calcium nitrate. There's calcium, there's nitrate. Look up your charges. Calcium is a positive 2, nitrate's a minus 1. So we need 1 calcium and 2 nitrates. Element with a compound. That's a single replacement. This is the element by itself. Try to replace one of these elements. This is a positive and that's a positive, so this is a cationic single replacement. Again, that means it's coming off of this list. So we need to look up here. So it's cationic single replacement. So sodium has to be higher on the list than calcium for this reaction to happen. Now, if we look on here, sodium is below calcium. So sodium cannot replace calcium. Elements cannot replace things above them. So sodium cannot do that. They cannot replace calcium. This is a no reaction. Reaction would not happen. You mix those two together, nothing would happen. Sodium cannot replace calcium in that situation. Other side of your sheet, I'm going to do number 9 and number 17. 9 and 17. Number 9 says that cesium burns in oxygen. So anytime something burns, it's always plus oxygen. So we got cesium plus oxygen. Cesium is not diatomic. Oxygen is diatomic. Burns means it's a combustion reaction. So plus O2. One thing that can be made here is cesium oxide. So cesium oxide. Don't take your numbers over. Look up your charges. Cesium's got 1 valence electron, has a plus 1 charge. Oxygen's a minus 2. So it'd be CS2O. Balance it out. We need 2 out in front of here. Nope, that's not going to work. We're going to need 2 out in front of here because there are 2 oxygen atoms here. That makes 2 there. That means we're going to need a 4 out in front of there. So it's a 4, a 1, and a 2. This also could be considered a synthesis reaction because you're taking 2 things and making 1. That's number 9. That would be, again, combustion. I'm going to do number 17. And maybe 16 also. We'll see. So here's 17. You got fluorine. Again, whenever you write an element by itself, make sure it's not diatomic. Fluorine is diatomic. Reacts with, so that's plus. Sodium bromide, which is a plus 1 and a minus 1 charge. So sodium bromide. Element by itself with a compound. That means it's single replacement. Okay, single replacement. That means we look at our activity series and see if it works. Well, if I look at my element involved here, fluorine is over here on this list. So fluorine has to be higher on the list than what it's trying to replace. In this case, fluorine must be trying to replace bromine because fluorine and bromine are both in this. This is your list of negative things replacing each other. This is an anionic, meaning a negative element, replacing another one. So this is an anionic single replacement. So fluorine trying to replace bromine, and it can. So we end up with sodium fluoride, fluorine to the place of bromine, +1, -1 charge, so we're good there. Plus bromine left over, and bromine is diatomic. Balance it out. You got 2 fluorines, only 1 fluorine, so double that. That gives me 2 NAs, 2 BRs. I think we're good there. The only other type of reaction not on this sheet that you need to know would be hydrocarbon combustion. Okay, so I don't have one on this sheet, but you need to know hydrocarbon combustion. So that means if I have a compound such as that, a hydrocarbon, it might have oxygen with it, but a carbon-hydrogen compound combustion means plus O2. And then whenever you burn a hydrocarbon like this, like methane, or this is actually ethane, or propane, or butane, whenever you burn one of those, it always produces carbon dioxide and water. I'm not going to balance this one out. You guys can do that part, I think. But whenever you have hydrocarbon combustion, you need to know plus O2 because it's burning, it's combustion, produces carbon dioxide and water. Remember, when you're balancing this, always do carbons first, hydrogen second, oxygens last.